Good evening, everyone, and welcome to Thursday Night Live with H New York. My name is Adam Jacobs. It's a pleasure to be here, as always, and I'm tremendously excited for our guest this evening, who's somebody that I've been listening to for more than 20 years and have benefited from tremendously. He is a scientist, and although there is a view in the world at large at the moment that science and theology are incompatible things, I sometimes think it's good to remind people that the entire scientific method was invented by theologians, religious people, for the purpose of exploring the universe in a way that revealed the divinity behind the universe. Again, that changed, but only relatively recently in history. In my estimation, times are changing back. We are starting to have serious scientists with doing serious research who are attempting to show that the universe has a creator, has a purpose, and has a design. This is not hokey stuff. These are serious people with serious credentials, and we have one of those individuals with us tonight. Mr. Harold Gans is a retired senior cryptologic mathematician with the U.S. Department of Defense, and the author of a recently published book, which is called The Cosmic Puzzle, which purports to scientifically demonstrate the existence of God. I read this book cover to cover. It's riveting, it's fascinating, and it's significant. And so to discuss its contents, I would like to bring on to the show now, Mr. Harold Gans.
Thank you very much. It's wonderful to be here.
Thank you for being here, and thank you for writing this extremely important book. Like you do, you start in your book with your credentials, and I think that is an important starting place that we have to establish for folks out there who may be of the opinion that science and theology have nothing to do with each other, and that all scientists reject theology. What is your background? And what exactly did you do for the Department of Defense?
Yes, that's going to have to be abbreviated because I can't speak about most of what I did, but I can tell you basically what I did. I was a senior cryptologic mathematician with the United States Department of Defense. My specific job after I got that title was to design the mathematical techniques that were used to break cryptologic systems, codes, if you will, ciphers of foreign entities that were considered our enemies or adversaries, military, diplomatic, and so on. Mathematics is the common language of virtually all of the sciences. And being a mathematician, and also, by the way, one of the strong points of a cryptologic mathematician are two things. Number one is logic. And I did have a very strong background in graduate school in mathematical logic. And the other thing is statistics. The combination is very, very powerful. To some extent, it's what's keeping our country going against the adversaries that we have. Mm-hmm. So applying this now to all the various sciences that seem to point to the existence of a power that created the universe, created life, that authored the Torah, and is also in charge of history, and trying to find what is not random about what looks random.
Right.
That's
code
what
breaking.
I'm doing for the Department of Defense, because their adversaries try to make their codes look totally random.
Right.
But they're not. They only appear to be.
Right.
So you have to be very clever in knowing the math and knowing the statistics and in deduction to figure out what is really not random about this so that I can put my finger into it. And that's what I did with the topics that I just mentioned over here that point to God.
Okay, excellent. So in addition to your mathematical and statistical skill, you do talk about biology and physics at length in your book, but you are not a biologist or a physicist. So would you say that compromises your ability to analyze this incredibly great question because you aren't equally expert in those other areas.
That certainly would be a possibility. And so to ameliorate that possibility, having gone through the necessary physics and biology and history that I did in order to write this book, looking at original papers, not what other people wrote about it, looking up the terminology and so on. But after I was done with it all, I gave it to several physicists. One of them was a senior physicist at the Johns Hopkins Applied Physics Laboratory. Another one was the head of the Space Exploration Division of Johns Hopkins Applied Physics Lab. The former chief engineer for NASA for spaceflight at Washington, D.C., a professor emeritus of biology at Johns Hopkins. So I had world-class experts, including popular ones like Gerald Schroeder, a well-known physicist, review the work and make sure that there were no errors. And sure enough, they did find some very small things that I had missed and made all the corrections. And then it went through more. And no one's found the mistakes since it's been fixed up.
Okay, great. So let's get a little bit into the nitty-gritty of your arguments. To start with, could you explain to our audience who may not be familiar with it, what you mean or what it means, the term cosmological constants, and why those constants are significant to us, and to the presentation you're making in your book?
Actually, the cosmological constant is not that important in terms of the book. What it is a constant that was put into the equations of general relativity by Albert Einstein. When he first produced his equations of general relativity, it turned out that they implied that the universe is expanding. And the popular belief at that time was that the universe was static. It was not expanding, it was not shrinking, it was basically always the same. And Einstein went along with that popular belief. And so he figured there must be something wrong with his equations. And he found that he could fix it by putting in this constant. Very shortly afterward, within a few years, it was discovered that the universe is in fact expanding, at which point Einstein said, oh, that was my biggest blunder. Nowadays, they're thinking about putting it back because of the discovery of dark energy. So the question is there really a cosmological constant? Isn't there one? That's still an open question.
Okay, so maybe I'm using the wrong term.
What I point out is that even a brain like Einstein, creative mind, couldn't break with the current knowledge, the current beliefs of his time. And that's something that we really have to be aware of, because to suddenly turn around and say, guess what? Science is showing you that there really is a God. You say, well, wait a minute, come on, no one says that. And we have to open our minds. We have to be sure to be totally unbiased and look at the evidence and evaluate it in a completely unbiased way.
So when I say the term cosmological constant, I'm sure maybe I'm using it inappropriately, but what I'm trying to get at is the fine-tuning argument, the various ways that the rate of gravitation, the weak and strong nuclear force, electromagnetism are tuned, and I'm calling that cosmological constant. Maybe that's the wrong term.
I'm afraid it was the wrong term, but
what's the right term?
Right. So the technical term for the fine-tuning is called the Theanthropic principle.
Okay.
It's almost accepted by virtually all scientists. The question that is the big controversy is not whether it is true, but rather why is it true? The Theanthropic principle basically is stating that virtually all the constants of nature, and I'll give you a few examples, are very finely tuned so that we can have life in the universe. And if any of them were just a little bit off, there could be no life in the universe. So, for example, the density of the universe, which means how much gravity there's going to be pulling everything back together, versus the expansion of the universe after the Big Bang. Clearly, if one is too more powerful than the other, either the universe is going to collapse right away and there's no universe to talk about, or it's going to expand so quickly that there will be no time for any structures to form. There'll just be a haze of fundamental particles. If you were to change either one, the density of the universe or the expansion rate, by 1 part in 10 to the 60, that's a 1 followed by 60 zeros, then you would have one of those two cases and there could be no life in the universe. The smoothness of the universe when it was first created. has to be in a very tight range between 0.00018 and 0.00019. If it's outside of that range, then again, the universe is going to end up either being clumps of black holes, which there could be no life in, or again, a mist of elementary particles. The gravitational force, what's known technically as the gravitational coupling constant, if it was just 3.9 times 10 to the minus 39 smaller, that means a decimal point and 38 zeros and a 3 smaller than it is, there could be no life in the universe. And it goes on and on. The question is this just chance? Or is it indicating that there's really something going on here that shouldn't be going on here if it was just random? That's my expertise. Therefore, I can look at what's the probability. Well, it turns out the probability was computed by Roger Penrose, a Nobel laureate in physics. And the probability of all of these, and I've just mentioned a handful out of maybe 20 or 30 different things that are finely tuned, is so small. It's a fraction 1 over, in the decimal, the number underneath the fraction is so huge, meaning that the whole fraction is very small, that it's more, the number of zeros in it would be more than the number of elementary particles in the entire universe. If there are any scientists listening, it's 1 over 10 to the 10 to the 123. It's an incredibly, unbelievably enormous number, meaning that the fraction is enormously small. That's the probability. No one's ever produced a probability that small. In any of the sciences for anything, I've never seen and I've never heard of a probability anywhere near that small. And that's saying this universe is highly unlikely if it were to come about by chance. Well, now, if it couldn't come about by chance in any reasonable way, then it means it didn't come about by chance. Someone did it. The next question is, well, who could have done it? Well, who could have created the universe except a being that's outside of the universe rather than being inside of the universe?
Yes.
And that's really the direction of the argument from this field of physics.
Okay, that's very well explained. So, taking it just a step further, there are those who believe that you get 100 monkeys typing, and eventually they will produce all of Shakespeare's sonnets, or the concept, in an infinite universe, there's an infinite number of possibilities. Is it not the case that given enough chances that the universe in this state will just happen to come about?
That is indeed true, if you had that number of chances. Now, first of all, you have really two possibilities here. One of them, well, three possibilities, really three possible that are talked about. One of them is, as you pointed out, an infinite universe. That's not the case, because if it was an infinite universe, first of all, we have no way to prove that it's an infinite universe. And if you can't prove it, demonstrate it scientifically, then it's just a fairy tale. There's nothing to talk about. We talk in science, we talk about what you can observe in one way or another or measure. What you can't see, what there's no way to see, is outside of the realm of science. So if you want to believe in an infinite universe, you can. And it's not going to make any difference, because if it's one universe, even if it's infinite, the same laws of nature will be the same everywhere. And therefore, you just bump the problem up one level and say, okay, so then why did this whole big infinite universe come out so perfectly for life to exist? So that eliminates one possibility. The other possibility is an infinite sequences of universes, one going into the other. That can't be because of the fact that the universe is flat. That is what the scientists call omega is actually equal to 1, which means that this is a flat universe, which means it did not come from a previous universe. It came from nothing. This is something which is agreed to by all scientists. So that's not even controversial. Now, the real one that's controversial is the multiverse, and that is that there's an infinite number of universes. So to this, I would say that the multiverse, first of all, is believed only by a small number of scientists. And the reason is that it goes against all science, because there's no way to, in theory, there's no way to ever detect another universe, even if it should exist, which means that there's no way to scientifically verify that there is, in fact, a multiverse. The only universe we can ever detect is the one that we are in. So therefore, talking about other universes is the same like talking about fairies. You can't prove that they don't exist, but you can't prove that they do exist either. They're not part of science, and I'll prove it to you. Gravitational waves. This is something that was discovered a few years ago. it was actually discovered, it was theorized by Einstein approximately 100 years ago by his general theory of relativity that gravitational waves exist. It was actually proven to exist in 1974 by Joseph Taylor and Russell Hulse, and they won a Nobel Prize for it. But they did not detect gravitational waves. What they were able to show is mathematically, because of certain conditions that were happening in a star system of neutron stars in space, therefore, the implication was that the only explanation could have been that they were generating gravitational waves, even though no one had the technology to detect it. Well, they got a Nobel Prize for it. They discovered gravitational waves. So does that mean that the search for gravitational waves stopped? No, indeed. LIGO, which detected gravitational waves a few years ago, was built at a cost of $300 million, and it cost $30 million a year to run it, plus another 7 of them in other different countries, including Germany, China, Japan, and other parts of Europe. Now, why are they spending all this money to detect gravitational waves? You know what they say? We require hard evidence. That's science, hard evidence. Not, I believe there's an infinite number of universes. I believe there are fairies. Prove me wrong. You can't show that I'm wrong, that there aren't fairies. Well, you can't prove me wrong that there's no multiverse. It's the same idea. And by the way, that's not the only thing. The Higgs boson, it was predicted by Higgs many, many years ago, back, I think, in the 1920s, the 30s. And it is a certainty mathematically based on the standard system of physics. In other words, it had to exist mathematically. And yet, $8.4 billion minimum was spent over a period of 40 years to build a Large Hadron detector so that we could detect Higgs boson if it really existed, because we needed hard evidence. Now, what the multiverse theorists say is, well, you know what? We believe that anything mathematical, if it's mathematically can be, then it must be. And mathematically, the multiverse might exist. But you know what? That's not true. And I have a very simple counterexample. The counterexample is a mathematical theorem called the Tarski-Banach theorem. It's a theorem in measure theory or in set theory, if you will. And what it basically says is that if I could take a ball made out of anything, a solid ball, let's say an iron ball, I can take it apart and to pieces, reconstruct it to form another iron ball that's solid of any size I like. Now, you say, that's impossible. Of course it's impossible in the real world. Mathematically, it's a theorem. You can do it. So you see that mathematics does not necessarily correspond in all cases to physical reality. And their argument is completely fallacious.
So would it be fair to say then that in your estimation, either there is an infinite number of universes which simply cannot be proven and it's not a part of science, or the universe must have been created?
That's true. And one thing that I did not mention is that although it's not possible to disprove the multiverse or to prove it one way or the other, because you can't ever observe it, nevertheless, one can build a statistical argument which shows with a very high degree of certainty that the universe that we're in is not a sampling of a multiverse. Meaning that the multiverse probably doesn't exist. You can't prove it doesn't exist, but you can show statistically that it's way out there. It really doesn't look like it exists.
Okay.
So it's actually evidence, statistical evidence against the multiverse, which means that we've got very, very powerful evidence for a creator of the universe. Now, we don't know anything about this creator at this point in time. We just know the universe didn't happen by itself. It had a creator, a very intelligent creator, who scientists have called a very, very advanced mathematician because he knew all the laws of nature.
So if that's the case, and it's so mathematically clear, the incredible unlikelihood of the fine-tuning the structure of the universe being what it is, you mentioned that that's basically accepted by scientists by and large. Why is it then that this isn't being hailed as the single most important discovery in the history of the universe? Why would you say that it's not been embraced and celebrated by the scientific community?
I think there are several reasons for that. But before I give you any possible reasons, I think that I would have to say that that question is outside of my area of expertise. Okay. You're asking a question in psychology, as opposed to a question in mathematics or in science.
Okay.
So therefore, I will have to say that I'm not answering you as a professional. I'm answering in terms of what I have observed and what I believe is at least part of the answer to your question. Number one is that this cognitive dissonance. In many cases, people do not want to know that there's a God. What is the difference between God and Superman? Superman is almost like God. He can do whatever he wants. Everyone loves Superman, and many, many people don't want to hear about God. And the reason is that when Superman comes and saves somebody, they say thank you, and he flies off, and they can do whatever they want. Whereas with God, he's sort of like all around watching you all the time, and people don't like that idea. So if people don't like something, then they may just reject it and say, I don't want to hear about it, or no, I don't believe in that. That's one. Number two is that there's a tremendous amount of peer pressure in the sciences and universities against people, even people who have who are there permanently and have tenure, against coming out and saying there's a God, or this shows that there's a God. And I've seen it in several of the papers. For example, the Tampa paper on protein science, which I quote in my book, he goes all the way and says, this is the only possibility. It could have come only from here and here and here. But he doesn't say the word God. He says, we have to think about this. There's something along those lines. He won't come out and say, this has got to be God, although he's proving exactly that. Now, there are probably other reasons too. And as I say, I'm not an expert psychologist. I would just say that the whole point of science is to try to be objective. And I just gave you an example before about Albert Einstein, of all people, who was not objective. And there are many other scientists who are not objective. There's a story in my book about Dr. Ignaz Semmelweis in the 1800s, who was beaten to death because he was claiming that people, that women who were giving birth were dying because doctors didn't wash their hands before they delivered babies. It only took about 60 or 70 or 80 years later when Pasteur discovered germs, and they said, oh, guess what? Semmelweis was right. Well, it was too late for him.
Right. So you're saying, I think, that that scientists are human beings, and human beings are subject to the forces of psychology, and therefore there is some degree of groupthink, of confirmation bias, and other factors that play into scientific discovery. Is that fair to say?
I would certainly agree with that.
Okay. Would you be able to give us, an example from biology? You do go into, very interestingly in the book, several examples of the complexity of biological reality. Could you explain how unlikely it is that those biological structures could have happened by chance?
Okay, that's a very good question, because let's take it one step further. In other words, here we have a creator of the universe that is created in such a way that it can sustain life. The next step, obviously, is, well, if you made a universe so carefully that it can sustain life, you would expect the creator would also create life if it was necessary, if it wasn't something that had to come about by the laws of physics, which it doesn't. And that's about what I'm proving, is that it can't happen by random, given all the laws of chemistry and physics. I approach it in two different ways. One way is through the structure of DNA. Now, DNA is present in all organisms that we know of on Earth. So the question is, how did DNA come about? Now, by the way, you might say, well, maybe on a different planet there is no DNA, but we're not talking about a different planet, we're talking about Earth. But if you want to go to another planet, experiments have shown, and I do quote this in my book, that without some kind of a storage system like DNA, an organism doesn't evolve into anything. It stays very, very simple, the most simple organism you can start with. So we're not talking about simple organisms. We're talking about some kind of life that can evolve, that can become complex, and so on. It turns out that the key in looking at this is not the biological problem of how do you get all of the components of the DNA to link together. That is a problem. And biologists so far have gotten, I think, as far as getting about 50 links together. Now, remember, when you're talking about 50 links, or what they call base pairs, in the human being, we've got over 3 billion base pairs. So we're talking about a very small amount, okay? The simplest virus that we know of has, I think it's 5,129. I'm not sure. It's 5,000 plus 1 or 200 base pairs. The question is, how would something like that come about all by itself? And we're not concerned with the biological problem, which may be solved someday. We're concerned with the mathematical problem of getting the information correctly. In other words, it's like a book. You can take letters and just throw them out at random. You're not going to get words. And if you even got a few words, they're not going to link together and make sense and be grammatically correct. DNA is a language. It's a 4-letter language, and it's specifying all the details of an organism. It's got to be correct. And there are many, many diseases that are caused by one base pair in a human being, one out of over 3 billion being wrong, a mutation. And it causes terrible things like cancer, diabetes, all kinds of things, mental retardation, on and on and on and on. And the reason that it's limited is because most cases, if you have one base pair wrong, the organism is not viable altogether. Although, in fairness, I have to point out that it is possible to have 1-point mutations which do not affect the organism. That is possible, but it's much, much less likely. So the question is getting the genome, the DNA of something like this virus, which is called PHYX174. I think it's 5,129, if I remember correctly. Base pairs correct, but not just one. You see, because what we want to say is, well, it had to happen once, but it had, let's say, according to science, the universe is 13.8 billion years old. So it could have happened anywhere in the last 13.8 billion years, anywhere in the universe. Estimated to be about 10 to the 81 or 10 to the 82 atoms in the universe. That's 1 followed by 82, 81, or 82 zeros. So it can be anywhere in the universe. I assume it's trying to happen with every single atom in the universe simultaneously, 1 million times a second for the last 13.8 billion years. And it doesn't only have to be PHYX174. It can be something similar to PHYX174. And the probability of that happening is a decimal point followed by 3,999 zeros and a 1. Now that's out of sight. That's virtually impossible.
I mean, would you say that's functionally equivalent to zero chance?
I'm sorry?
Is that sounds functionally equivalent to zero? I mean, like, isn't that?
Yes, that's right. It is. And I would say to anyone who says, well, yeah, but it's still possible. And
right.
Theoretically, it's possible. But no one in their right mind guides their life by a probability that's so small. And the standard is, what do I do? I mean, how sure do I have to be about marrying someone before I'm sure that they're the right one? Do I want a probability of 10 to the minus 4,000 that she's perfect? It doesn't make sense. I'll never get married. So you have to apply real life criteria. This is beyond the real life criteria. The second approach is to look at something called the interactome, which is the communication network within a cell. And again, using the same approach, and this is based on the findings of Tampa et al., which I quoted before, the probability of the interactome coming about all by itself is a decimal point followed by 7,055 zeros and an 8. Again, this is even more unlikely than the DNA. Now, it's interesting to point out that Professor George Wald, who was an atheist, has said, well, you know what? He gave the same argument as Rabbi Jacobs, and that is, well, give it enough time, billions of years, anything can happen. If it can happen, it will happen. You just have to wait long enough. In his later years, he wrote an article in the journal Quantum Chemistry, in which he changed his mind, and he says, clearly, there was some kind of a mind that designed the universe and life. My suspicion is he finally did the computation that he was afraid to do all those years and came up with the same kind of numbers that I came up with. And he was being open.
So on two levels then, the structure of the universe itself, and then the biological structures, however they came about.
Your sound is breaking up. I can't hear you.
I'm saying that there's two components of the argument as we have it thus far.
Could you start again? Because until now, I wasn't hearing your voice.
Okay, can you hear now?
Yes.
We good? Okay.
Yes.
Just to summarize for the audience, there are two facets of your argument thus far. One is that the underlying properties of the universe itself, not biological matter, just matter itself, is primed for life to exist in such a way that precludes any type of normative probability. It's so unlikely that in your estimation, we must conclude that it was purposefully executed. And all the more, Yes.
interruption, not in my estimation. If you compare it to the standards of statistics in any of the sciences, in any experiment done, they don't compare it to the standard over here. So it's not
Right.
just my estimation.
Right. This is far beyond a normative expectation of what it should be.
Correct.
Okay. And then to compound that, once we have life, of course, which science still does not have, has not developed a theory of how it came about, the process of abiogenesis, we have another problem of trying to explain the extreme complexity of those biological structures. Again, according to a statistical analysis, highly unlikely, perhaps so unlikely, approaching zero on the scale of likelihood. And therefore, a second facet to the likelihood, at least according to your book, which I recommend everyone should read, of there being a creator to this universe.
That's correct.
There's an even better copy of it. Okay. Fine. That's pretty powerful as far as I'm concerned. We have the psychological resistance apparently from others, which will be interesting to see, what the impact is going forward and if people come around. I know that there is a concept of a revolution in science, and being various stages of scientific development and certain stages of acceptance of how a theory becomes accepted by the general public. And maybe, I'm hoping, that as time goes on and more work like yours penetrates out there, that people will come to see that there's a lot more to take seriously here than maybe people considered before. But be that as it may, I'd like to take it even another step further and go.
I'm sorry, your voice is off again. It's scrambled.
How's that? Better?
I'm not hearing you.
Ooh, what am I going to do about that? Mr. Producer, do we have a solution for that? How's that, Mr. Gans?
Okay, got you now.
Okay. Let's take it a little step further into a more controversial area. And that is the notion of patterns existing within the text of the Torah itself. I know you've worked on this for many years. I also know that it's extremely controversial. Would you be able to give us just a general outline for a few minutes of what do you mean when you say that there are patterns in the Torah?
Okay, these are popularly called Torah Codes. And there is information which is encoded in the Torah. And by Torah, I mean the 5 books of Moses, but the original Hebrew of the Torah. The way it's encoded is by equidistant ladder sequences. That means that words are encoded with a skip distance between the letters that's always the same. So you have one letter of a word, and then maybe 23 letters later, you have the second word, 23, you have the third word, 23 letters further, the fourth word, and so on. It doesn't have to be 23, it can be any number, so long as the distances from between each of the letters is equal. And then sometimes you have 2 or 3 words that appear in a certain configuration, which we call close proximity, which is a mathematical concept which has a geometric interpretation. It doesn't mean that it's going to be close in the Torah scroll as you look at it. But it can be displayed in a way that's close, but it has a very distinctive mathematical formulation. The first discovery of these, I mean, it's mentioned in books going back to the 13th century. I think Rabbeinu Bechaya, on his commentary in the book of Genesis, first mentions it, and Rabbi Moshe Cordovero in the 16th century, Sfas, mentions it. He was the Rebbe of the teacher of the Arizal, one of the greatest mystics of all time. The mathematical approach was pioneered by Doron Witztum and Eliyahu Rips, going back to the early 1990s, I believe, or late 1980s. They did something called the Great Rabbis Experiment, in which they showed that this proximity formula works for names of great rabbis who lived between the 9th and the 18th century, who they got the names out of an encyclopedia, and their dates of birth and death. It was published in the journal Statistical Science in 1994, and that's when the controversy was ignited. And the controversy really centered, without getting into technicalities, the controversy settled on the fact that in the experiment that they did, there were certain decisions that were made that were not transparent. They claim they were transparent. Maybe they are transparent, but you have to know a lot about rabbis' names and how to write them and so on in order to see that it's transparent. And several people did that and said, yes, it follows a well-ordered form. But it's not obvious to the general public. And this came under fire. If the experiment is flawed, it does not mean that the results are wrong. What it does mean is that you can't decide for sure that the results are right. In other words, it doesn't invalidate the results as being true or false. It doesn't show in the way, one way or the other. What it shows is that the methodology that you use to determine that the phenomenon is true is flawed. Now, if you could fix the methodology and then show that you get the same results, then of course the controversy would be over. And that is precisely what we did. I wrote a paper. I did an experiment called the cities experiment, in which I took the very same names of the rabbis, paired them with the cities of birth and death instead of with the dates of birth and death. By the way, the probability of it being random that we got for the Great Rabbis experiment was 1 in 62,500. The paper was published in 1994. The cities experiment, the probability is 1 in 250,000 that it could have just happened by chance, well beyond the peer reviewers who claimed that the level was just 0.001, 1 in 1,000 would be sufficient. That was published, the cities experiment was published in 2006 and was published through peer review. That means that probably non-Jewish mathematicians, we have no way to know who they are, reviewed the paper. Now, in that cities paper, I quoted what the critics have said about the Great Rabbis experiment. I referenced their website, in which they go to all their details. I referenced their paper that they published in 1999, also in Statistical Science, and made the claim that this answers the question, that this shows that, in fact, not only is the cities experiment a success, and it is not subject to the same problems that the Great Rabbis experiment was, because we changed the methodology so that we would take care of those problems, but it actually showed logically that the Great Rabbis experiment was correct as well. Even though the methodology left something to be desired, the results nevertheless were correct, meaning that it wasn't forced. It wasn't a hoax, for example. Now, the fact of the matter is that was 2006. We're now in 2020. How many years is that, Rabbi Jacobs?
I think it's about 14.
About 14 years. It's actually about 14 and a half years by now. And in 14 and a half years, no one has refuted the cities experiment. No one has shown any fatal flaw in the experiment. In fact, the critics have been very, very quiet about the whole thing, which means they've basically given up. At least that's the way any normal person would interpret it. You know, you've shown, hey, guess what, guys? You're wrong. Here's a paper that proves it. And no one says anything. 14 years later, they still haven't said anything. Clearly, it would seem to me that they have nothing to say. The question that now comes up about these Torah codes, and there are many others, by the way. There's one about bin Laden, which is the longest such equidistant letter sequence that was found. It was published also in 2006, a result by Art Levitt. The probability of that being chance is 1 in 2,500,000. The question then becomes, given that these codes are there, and it clearly are because they've been published through peer review, no one's been able to refute them. All the data was, by the way, was put online for anyone to look at and to find the flaw in the data, any mistakes. No one has come forward with any problem with anything, either the methodology or the results or mistakes in the data. The question is, who could have done it? Okay, it's not random, but maybe some person could have done it. Well, thinking about the fact that the Torah is forgetting about our tradition. Our tradition says it's 3,300 years old, but even according to secularists, the Torah is a minimum of 2,000 years old because it was translated into the Greek approximately 2,000 years ago under the reign of Ptolemy II of Alexandria in the Pentateuch. So we're talking about a 2,000-year-old document that has the dates, the names and dates of birth and death and of cities of birth and death of people who would live until the minimum, the 9th century, all the way up to the 18th century. Who could have known the future like that? Clearly, humans back then couldn't have done it. So when I give talks about this on the West Coast of the United States, people will say, well, maybe aliens did it. Well, as it turns out, they have some kind of a technology that they can foresee the future. It turns out that they can't do it, and I can prove they can't do it. Using chaos theory and using the uncertainty principle of quantum mechanics, The demonstration is in the book. I can show that predicting the far future in detail is something which is beyond the laws of nature. It's beyond the laws of quantum mechanics. Therefore, it means the author of this is beyond the laws of nature. It couldn't have been an alien, even if alien exists. I don't know if they do or not, but even if they did exist, they couldn't have done it. The only other possibility is time travel, people traveling back into the past with information from the future, and that turns out to be logically inconsistent. It's called the grandfather paradox. Stephen Hawking has a version of it called the mad scientist paradox. It's again in my book, but you can show logically that it's time travel into the past is not possible. Into the future it is possible, but into the past it's not possible. So that's basically the results that I have in terms of the Torah being a divine document.
Okay. So again, one would think that this would be hailed as amongst the greatest discoveries in the history of the world. Nonetheless, it's been met once again with perhaps I would say much more scorn and animosity than the fine-tuning argument has been met with. But, I think if I'm speaking for people who might be hearing this for the first time or have considered it and rejected it, if I said to you, listen, it just sounds so far-fetched. I mean, like, what do you mean that there's equidistant letter skips in this book, in this ancient book?
Your voice is off again.
How's that?
Yeah, good now.
If I'm asking, doesn't this all just seem so far-fetched? How can I possibly believe that there are these messages about the future in this ancient document? Isn't it just too much to really accept?
You know something? You're right. And when I first heard about it, I thought it was total nonsense, and I didn't even look into it. It was only about a year later, after I heard about it from a cousin of mine, that my wife insisted that I should take a look into it and see if it's true. Why? Well, because I'm interested in Torah, and in spite of all the people with PhDs who have said, no, this can't be true, the critics who published the papers that I mentioned before, I think I have more experience in codes than they do. I'm a senior cryptologic mathematician. This was my bread and butter for 28 years. But you don't have to rely on me. The fact of the matter is that just take a look at the history of this. You'll see my paper published in 2006, the 18th International Conference on Pattern Recognition and the proceedings of that conference. Take a look at the literature afterwards. See if anyone refutes the cities experiment. All the critics talk about is the original rabbi's experiment. And when we challenge them to say, well, okay, what do you say about the cities experiment? Their response was, and of course, there's no way to know this, but I know because I got the response, and that is, we already did our work with the great rabbi's experiment. We don't have to waste our time with this anymore. So, if the fact of the matter is that peer reviewers who have no reason to want to show that this is true, in fact, we don't even know who they were, so they could have said anything they wanted. And they're probably not Jewish. We have no way to know if they are or not, but I would assume that probably not. And they accepted it. They looked at what the critics had to say and they said, yeah, you've answered all the questions. It's true. It was very controversial. The controversy has been over since 2006. And, anyone could look at it and see, has anyone refuted it since then? And if the answer is no, then the conclusion is, well, why haven't they? If they're so much against it, why haven't they shown, hey, no, Harold Gans is wrong. No one's done it. And you know what? If you have a friend who's mathematically savvy, show him the proof. Show him the original papers. Say, this bothers me. I can't believe this kind of stuff. Can you show me where did they make a mistake? And see if you can come out with a mistake. I'll be glad to address it. In fact, I had an interesting experience with a mathematician who knew me professionally. We worked together occasionally when in my life with the Department of Defense. And he heard me in the early days. He heard that I was involved in the code research. Why? He says, why are you involved in this silly stuff? Nonsense. You of all people. I mean, you're a mathematician. You're very based, grounded. What's with you? I said, something, David? I said, I've looked at this as carefully as I've looked at anything here at the agency. By the way, I published over 100 papers internal. They were classified in the agency that I worked for. And no one ever found a single mistake in any of the papers. Not because I was so brilliant. I was very careful. I was very, very careful. And I said to him, you know what? Next time we see each other, how about I show you this and you show me if you can find the mistakes? No, I'm not interested. I don't want to see this anymore. That's a true story. Because he knew that if I couldn't find the mistake, it was unlikely that he was going to find the mistake. Yes, it is far out, but check it out. Unbiased. Go into it totally unbiased and give it a shot. Give it your best shot. Look at it and see, is there a mistake in the work? And if there isn't, well, draw the obvious conclusion.
2 more questions, and then we will entertain some questions from the studio audience. How do we know that the Torah, the text of the Torah, isn't radically different than it was in ancient times? I mean, don't we have a concept of broken telephone where there's a degradation of information? I mean, why should we believe that the codes could possibly work when we should assume that the Torah is quite different than it was previously?
That's a very, very good question. It has been raised by a number of people. First of all, people often point out that if we look at ancient manuscripts of the Ashkenazi or Sephardi Torah, there are many manuscripts that differ sometimes by hundreds of letters from the current version of the Torah that we have today. But one thing that's very interesting is that they don't differ by any words. That's number one. Letters, yes, but the words are all the same, because you see in Hebrew, there are different ways of spelling that are correct, of spelling the same word. You can sometimes put a vav in or not put a vav in, or a yud or not a yud, to give the pronunciation of the word. They can be spelled correctly either way. And so there was questions about it, but the words are all the same. That's number one. Number two, the Yemenite Torah has been the same all the way back to thousands of years. We have ancient manuscripts of the Yemenite Torah. They're identical to the Yemenite Torah of today. And the Yemenite Torah of today differs from the Ashkenazi Torah by 9 letters, which means that the Ashkenazi Torah, whatever those ancient manuscripts may have been, the one we have today couldn't have changed by more than 9 letters. That's the implication. That's number one. Number two, the Bin Laden code that I mentioned before is 29 letters long. The fact that that code exists and has the probability of being random of 1 in 2,500,000, the question now becomes, could it still be there if there was some kind of degradation of the Torah accuracy? And the answer that I come up with is that with a probability of 99.9%, we couldn't have dropped or added more than 9 letters in the Torah. That's a mathematical result. Dr. Breuer did a study in which he did a majority vote of 4 ancient manuscripts of the Torah dating back I think to the 9th century, plus 1 printing of the Torah, an ancient printing in Venice in the 1500s. He did a supermajority vote. In other words, if you got 4 letters the same and 1 different, you said, okay, it's obviously going to be the 4 letters. These were from different localities, different ages, and so on. And when he went through that process of the entire Torah, what he came up with was that in the end, there were 6 letters that he couldn't resolve as to what they were. And the remaining 304,799 letters were identical to the Yemenite Torah, which means that the Torah is 99.997% accurate. The other Torah codes, the same thing. You drop 1 letter out of every 1,000, the Great Rabbi's experiment goes away. Similarly for the city's experiment. So rather than saying that there is inaccuracies in Torah, and therefore the codes could not be there, and therefore they must be false, I turn it the other way around. So we've demonstrated beyond any reasonable doubt that the codes are really there. And that implies that the Torah must be accurate, aside from all the evidence of the ancient manuscripts and the codes and the Yemenite Torah and so on.
Okay, excellent. And last question from me, which is, to me, you've established that there's a creator. I'm quite comfortable with it. I read the book.
I'm glad we convinced you. Right?
I was pretty good with it before, but now I'm even better with it. And well, is there anything, Mr. Gans, that we can do mathematically to demonstrate that this creator still has a stake in his creation, that he still cares or interacts with it in some way?
Absolutely. And that was one of the most difficult challenges. How do you analyze current events in history in a mathematical way? And it turns out it is possible. And it actually was done. People will recall the Persian Gulf War of 1991. Turns out that there was a paper, a scientific paper, it was published in the British journal Nature, which is one of the premier scientific journals in the world. One of them is Nature, which is the British one, and the other one is Science, which is the American one. And the title was, Why Were the Scud Casualties So Low? The scientists and military experts had noticed something funny was happening with the Scud casualties in Israel. There were 2 people who were killed. They expected more. Well, in this paper, they actually go ahead and do the computation. There's a formula, as you might expect. The military would develop a formula. How many people do you expect to be killed by a rocket with a warhead exploding in a populated area? And of course, you have certain parameters. For example, what's the population density? What's the power of the warhead? Do the people have warning that it's coming in or not? And so on. You expect the 21 to be killed. You expect 21. You observe 2. That's very, very few. You expect 61 people to be seriously injured. Only 11 were seriously injured. And the conclusion that they come to, and this is an example of something I told you before, the conclusion they come to is there's no answer except that it must be luck. Okay? And one of the examples they give is this apartment building collapses. People are buried in the basement underneath, all the rubble with electric cables and gas lines ripped open. They take away all the rubble and everyone walks away with a few scratches, and that's it. And that happens over and over and over again. By the way, this is taking into account not 39 scuds that were fired, only 14 that actually exploded in populated areas. We're not talking about the ones that missed. We're not talking about the duds. We're not talking about the ones that went into the Mediterranean or the wilderness or that were shot down by the Patriots. We're talking about the ones that actually exploded. There were 14 of them. You expected 21, you observed 2. What they do not do is they it's just luck. They do not calculate what's the probability of that happening. Okay? There's a reason. Because if they did, they would be stuck. What are they going to say? They have nothing to say. They don't want to mention God, or their paper will never get published. But you know what? I know how to calculate probability. So I calculated the probability. By the way, the calculation, the book, is written for the layperson, but there are endnotes at the end that give all the calculations, all the formulas, so any mathematician or scientist wants to check them out to your heart's content. Try to find the mistakes. The probability is 5.4 million to 1 that only 2 people would have been killed when 21 were expected to be killed. In terms of the injured, 11 people were injured, 61 were expected. The odds are 234 trillion to 1. That's not happening by chance. And by the way, in case you think, well, maybe there was something very, very special about this war, right? In 2006 Lebanon war, you have similar results. You have 53 people were killed, but only 132 people were expected to be killed in that war by missiles. Odds, 203 trillion to 1. In terms of injuries, 18 trillion to 1. And the same kind of results for the 2008 Gaza war. Someone is who can protect people in a building? By the way, the number of buildings destroyed goes according to the formula. The buildings are not protected. Only the people inside the buildings. Who can do that? Who is going to control which gas line is going to open, where a fire is going to break out, which electrical cable is going to touch what, where the steel beam is going to form, where the concrete is going to fall, and where all the people are so that no one's going to get hit by anything? Who could possibly control something like that? 3 different wars in which I've done that calculation. Cumulatively, the probability is 1.2 billion trillion to 1 that it could have happened by chance. And by the way, if you take a look at scud casualties, same scuds, in other places all around the world, including Saudi Arabia, including Yemen, including Chechnya, you will find that the average number of deaths per scud is a little over 18. 18. And over here, in Persian Gulf War, 14 scuds killed 2 people, and anywhere else, the average is that each one should have killed 18. So, draw your own conclusion. Simple logic. God is still here.
Okay, so to summarize, the structure of the universe strongly seems to indicate the existence of a designer. The universe is designed for life. Biology seems designed as well. The chances of the complexity within biology existing by itself is infinitesimally small. To boot, there are equidistant letter skip coding within the Torah itself, which have an extremely unlikely probability of existing. And furthermore, if that weren't enough, Mr. Gans has shown that there seems to be a divine oversight, at least in some quarters, within history itself in a way that is extremely unlikely to occur. All that is quite amazing, if you ask me, and I would say to our audience, like he said, don't just take it at face value. Open the book. I recommend this book, Cosmic Puzzle. Think about it, read it, see how it impacts you, see how it strikes you, and do the research yourself. Don't just believe what is being presented here, and see if you come up with an alternative, and let us know what that is. In the meantime, Mr. Gans, we have 3 minutes, and we do have a couple questions that I'd like to get to, so let's do 1.5 minutes per question, and see if we can pull that off, okay?
Sure.
Number one, can you explain why not only the mathematics and statistics community in general rejects these claims, but numerous religious mathematicians as well, including top mathematicians such as Robert Aumann?
Again, this is something which is outside of my expertise. There are all kinds of psychological reasons why. I would point out that Professor Aumann in particular did not point out what the mistakes were in the research. He simply tried to reproduce some experiments, or some other people try to reproduce some experiments. There's a whole discussion of it in the first appendix in my book. But each individual may have different reasons. I do know that one university professor, from person, was basically told by other professors, "Do you believe in this stuff?" He said, "No, I don't believe in that." So again, there's peer pressure, there's cognitive dissonance, and even for people who do believe in God, they don't want it shoved down their throat. They don't want someone to say to you, "Guess what? It's really real and I can prove it." They'd rather say, I believe, because it gives you more latitude. I believe this, I don't believe that. Well, I sort of believe it, so much so people don't like to be forced into a position. But what I'm telling you is that regardless of how it may feel to you, if you're interested in the truth, if you really, really want to know the truth, you have to pursue it, regardless of how it feels inside, whether you want to know the truth or you don't want to know. Usually, people are better off knowing what's true than not knowing what's true.
Okay, we've got 45 seconds for this question. Are there predictive models based on the Torah codes? If so, what are their results?
The answer is no. Several people have indeed tried to predict the future based on the Torah codes. Every single one of them has failed. And there are reasons why they fail. It's kind of technical, but what I would say is there is a logical problem. The simplest way to explain it is that if there is a historical event which is true, then the words describing that historical event will, with a certain high probability, be involved in some kind of a code. But that's looking at the past. For looking in the future, you have to look at the words in a code, in a so-called code, and then project backwards as to this means that in reality, this is what happened. And that doesn't work. Just because you can go in one direction doesn't mean you can go in the other direction. Just because all cats have 4 legs doesn't mean that any animal that has 4 legs is a cat. So that's a false logic. That's called the converse logic. Another problem is that we haven't broken the code, so to speak. We don't know how to read the code. So, like, for example, one person was looking at an election, a prediction for an election, and it said so-and-so will rise, so-and-so will fall. And that was his prediction. Came out the other way around. Reason, he overlooked the word lo, which means no in Hebrew, near both of them. So those are simple examples why. There are other examples, technical reasons why you can't do that, even though people continue to try and continue to fail.
Mr. Gans, thank you so much for being here this evening. This was, as always, extremely illuminating. I think the work you do is critical and highly engaging, and the book you've written is just an excellent read. And again, I recommend it for everybody, The Cosmic Puzzle. Check it out and draw your own conclusions. But for now, that is our program for Thursday Night Live. We'll be back next week at 8 o'clock. Thank you all for tuning in, and have a great night.
And thank you so very much for having me. I appreciate it. Good night, everybody.
Good night. My pleasure.